2.2, we're going to take a look in section 2.2 at some rules or laws of differentiation. So coming out of section 2.1, we defined the derivative of a function as the limit of the difference quotient. And we looked at extensive examples where we had to find the derivative either at the point or the general form of the function, the derivative function, using the limit definition, limit of the difference quotient again. So we don't want to do that beyond section 2.1. So that was a passing phase. We need to know it for that section again, but not in future sections. So what we would like to do is develop these limit laws. Now, all of these theorems that you're looking at it on my screen here, the proof of these are in the book if you're interested to look at the proof, but we're going to actually take a look at the exercises here. So again, for interested reader, you're welcome to look at the proof is in the book. They're not difficult. All of the proofs are proved using the limit of difference quotient. So anyhow, let's proceed. This is a rather brief section. There's not much in here. We only have 5 theorems. The first theorem, Theorem 1, which is this one. Okay, this Theorem 1 tells us that the derivative of a constant function is 0. And you can kind of see why that is the case. Let me draw something real quick here. So let's say here I have a constant function. Okay, and for that constant function, remember, if you look at the change in y over change in x, well, there is no change in y as you go from one point to the next point. So delta y is 0. However, there is a change in x, right? So there is a delta x. But if you take the limit of delta y over delta x is going to be 0. So that's not a formal proof, but if I put the details in it, it would be a formal proof. And so anyway, let's go through this. Theorem 1, derivative of a constant function. Derivative of a constant function is 0. And we notice we're using d dx of f of x here. Theorem 2 is commonly known as the power rule. This is the general power rule. If n is a positive integer, then x to the n, the derivative of that is going to be n x to the n minus 1. A special case of this is when the exponent is 1. When x is 1, you can see that, let me show you how this works. The derivative of x to the first power, prime notation I use for the derivative, you bring 1 in front, subtract 1 from 1, you get 0. X to 0 is 1, assuming x is not 0. Okay, and there you go. So that's what this is. The derivative of x is 1. Now you can also again look at this one in terms of the linear function. Remember, function x is a line running through the origin, bisecting the quadrants. So this is x. The slope of this line is always 1, isn't it? So the tangent at any point is going to have the same slope as the line. Therefore, the derivative, which is the slope of a tangent line, is going to be 1 at that point. Okay, Theorem 3. This is the general power rule. It looks just like the power rule here and the power rule there. The difference, so what is the difference? The difference is this here. He assumes that n is a positive integer. So for example, n is going to be 1, 2, 3, and so on. Whereas in here, n is any real number. Okay, so you can pretty much think of this theorem, Theorem 2, as a subset of Theorem 3. So all you need to know is really Theorem 3. Okay, Theorem 4 is the constant multiple rule of derivatives. So if you have a constant multiple of a function, you want to find the derivative of a constant multiple of a function, all you got to do is bring the constant out and simply take the derivative of the function. Theorem 5 is the last one. It's the sum rule. And of course, because we view subtraction as addition with opposites, so he doesn't have a separate difference rule, but the sum or difference rule actually plus minus, it works with both versions, okay, with both of them. Now let's take a look at some of these exercises. Okay, so let's begin with, and I have actually circled the ones that I'm going to look at. Feel free to look at ones that are nearby, but this is the focus of our exercises in this section. So let's begin with exercise number 2. In exercise number 2, we have a linear function, right? So we have here I have f of x is equal to 3x plus 4. Okay, we want to find the derivative in all of these. So f prime of x is going to equal 2. Now, I'm going to put maybe more steps than you would, but this is just to kind of see how these rules work. We can, and we will use more than one rule at the same time for the same problem. Okay, so you don't have to just use one rule. We can use a combination of rules. So if you look at this one, this is like a polynomial function. This is in the form x to the n, a constant times x to the n, right? 3 is a constant, and here you have x to the n. Plus, this is a constant, right? That's what I'm thinking when I look at that. Well, what is the derivative of a constant, right? d dx of a constant is 0. And the constant multiple rule here tells me that d dx of a constant multiple of x to the n, I can bring the constant out and simply take the derivative of x to the n. And we do have the power rule for this, right? You bring n to the front of x, this n moves to the front. So we bring n in front of the x, and then subtract 1 from the exponent. Okay, so this is what I'm going to do with this exercise. First, derivative of, we're doing this part. So 3 is a constant multiple, and derivative of x, we had it up here. Remember, the derivative of x is 1, so you can just put 1 there. 3 times 1 plus derivative of a constant is 0, so the answer is 3. Notice that is the slope of that line, isn't it, in the mx plus b form? So without using the limit of difference quotient, we were able to find the derivative. That's all in exercise number 2. Let's take a look at number 8. And in all of these exercises, by the way, no matter how exotic or different it may look, because we only have those fixed rules, so everything has to conform with the rules so we can use our derivative rules in these exercises. Number 8, f of u is 2 divided by square root of u. Again, we don't have a rule for the square root, right? So that means I have to rewrite this. Now, square root of u would be u to negative 1/2, wouldn't it? And not the square root of u. Square root of u, of course, is u to 1/2. But because the square root of u is in the denominator, we can use negative exponent rule and bring it into the numerator. So we can now write f prime of u, that is the derivative of the function whose independent variable is u. That's going to be, again, a constant multiple. And we're going to use the power rule on this. The negative 1/2 moves to the front. Here's u, negative 1/2 minus 1 in the exponent. So this is going to be negative u to negative 3/2. And there you have it. Now, usually what we do, by the way, in the way of the answers, how we report the answer is important. We give the answer as much as possible in the form of the original problem. So if you look at number 8, we don't have negative exponents like I'm looking up here in number 8. We are given square root. So I'm going to rewrite this as negative 1 over u to 3/2, right? That's good enough for our work. We don't have, again, we don't use negative exponents. We try to use positive exponents. Again, this answer is not wrong. It's just not complete. We have to simplify all answers. Okay. That was number 8. Let's take a look at number 14. In exercise number 14, I have y is equal to negative 1/3 of x cubed plus 2x squared plus x minus 1. Okay, so let's take a look at this one. Now this one is a combination of addition and subtraction of terms, which indeed translate into addition and subtraction rules of derivatives. So y prime, you can write it in that form. Since they're giving me y, I give them y prime. Constant multiple on the outside. The derivative of x cubed is going to be, you bring 3 in front, write x, subtract 1 from 3, we get 2, plus 2 times constant multiple. Derivative of x squared, bring 2 in front, subtract 1 from the exponent, plus derivative of x is just 1, and negative 1, that means you subtract, so minus derivative of a constant is 0. So this is going to be negative 1/3 3x squared plus 4x plus 1. And there you have it. That is the complete answer for number 14. In number 19, let's see, for number 19 I have x cubed negative 4x squared plus 3 x cubed negative 4x squared plus 3 divided by x, and that was f of x, right? And this was exercise number 19. Okay, so for this one now, again, we don't know about the quotient rule. Okay, so if some of you have had calculus before and you know about quotient rule, we cannot use it, not in this section, okay, because we have not talked about it. If we haven't talked about it yet, we cannot use it. Think about it this way. Somebody may have had calculus, they know about quotient division rule. Some of the students, is the very first time they're seeing this. They have no idea what quotient rule says. So in each section, we have to build up to whatever it is we are building up. We use the methods of that section. Later on, when we are done with all the rules, then sure, you can use any property, any rule of differentiation. But for now, we don't know about the product rule, we don't know about the multiplication rule of derivatives, so we have to stay with what we know. So what does that mean? That means I can actually do this. I can write this as x cubed negative 4x squared plus 3, and then invert and multiply the x as negative exponent. Okay, this x in the denominator goes to the numerator with the exponent of negative 1. And then I can multiply, actually distribute, right? X to negative 1, x cubed times x negative 1 is x squared. X squared times x negative 1 is x plus 3x to negative 1. And note now, we have a new expression, Now we can find the derivative using our derivative rules. Again, each of these is in the form of x to the n. Each one of those terms, I have difference and sum of functions. So derivative of difference or sum would be sum or difference of derivatives. Okay, so that's what we're going to do. Derivative of x squared is going to be 2x. Derivative of negative 4x, well, negative 4 is a constant multiple, so that's just 4. Derivative of x is 1. For the next one, that's going to be 3 times. X to negative 1 is negative 1. X to negative 1 minus 1 becomes negative 2. So this is going to become 2x negative 4 minus 3x to negative 2. Okay, so we're going to rewrite this as 2x minus 4 negative 3 over x squared. Now this is okay, this is fine, because we don't have a negative exponent. You could, you don't need to, not for my purposes, you don't need to get LCD, write 2x cubed negative 4x squared minus 3. If you did, that's above and beyond. Okay, but this is not necessary, the very last step. The answer just prior to that. This answer is good enough for my purposes, as long as we don't use negative exponents. Okay, now one thing, let me real quick mention about this constant multiple, because some students have asked me before. They say, well, 5x, let's say I want to find derivative of that, and well, we know derivative of 5, right? 0. What is derivative of pi? 0. Derivative of e? 0. These are all constants. Now, when we say constant multiple rule is this, that means you can actually bring 5 outside and then take the derivative of simply x, and that's 1, so that's 5 times 1. So it's not like the derivative of a constant is 0 here, because we never had a constant. We have a constant multiple. We don't have a single constant by itself whose derivative we want to find. Okay, so hopefully you follow that. Now, let's take a look at, I guess I could leave those on there, but I just want to clean the slate. All right, so there's number 19. We're good with number 19. Let's take a look at exercise number 22. This exercise is rather lengthy, so let me actually copy and paste it down here for a moment. Okay, and there you go. That problem is now copied and pasted into my note. So let's take a look at now this exercise. So for this one, again, we have a combination of constant multiples. These are the constant multiples, okay? And then we have a combination of subtraction and addition of terms. So remember, the derivative of sum or difference of a function is going to be the same as difference or sum of the derivatives of the function. So that means f prime of x is going to be, constant multiple is here, 5. Now I'm going to bring 4/3 in front, x 4/3 minus 1, right? 4/3 minus 1, negative 2/3. Bring 3/2 to the front, x to 3/2 minus 1, plus x squared, bring 2 in front, subtract 1 from 2 in the exponent. Constant multiple, derivative of x is 1, derivative of a constant is 0. Now later on, I'm not going to put as many steps when we do these, because then they take too long and there's room for error. So we'll skip some of these intermediate steps later on. So this is going to be 20/3, and then x to 4/3 minus 1 is 1/3. Negative. Well, these are reciprocals, they multiply to 1. That's going to be 3/2 minus 1 is 1/2, plus 2 just x minus 3. And we are good with this one. Again, you don't need to manipulate that any further. We're done with number 22. Let's take a look at, that was 22, in number 26. Okay, let me bring 26 down. Okay, so let's take a look at number 26 now. In number 26, and let me bring it up a little higher. There you go. And I went ahead and wrote 3032 already, so I don't have to go back and forth. Okay, again, notice we have quotients. The variable is in the denominator, so we have quotients. We cannot use quotient rule because I have no idea what quotient rule means and how it works. So let's actually rewrite this in the form that translates into individual terms that are in the form of x to the nth power. Okay, so the first one is 5 over x cubed. That's 5x to negative 3 power. Negative 2x squared becomes x to negative 2. Negative 1 over x becomes x to negative 1. And of course, the constant is there. Okay. Now notice we have individual terms that are in this form of x to the n. Now we can proceed with the derivative. So that's going to be 5 times. For x to negative thirds, bring negative 2 in front of the x and then subtract 2 from the exponent. For x to negative 2, we're going to go negative 2, bring negative 2 in front, subtract, oh, actually I missed this one. I did say it, I didn't write it well. Negative 3 minus 1 is negative 4, not 2. So negative 2 minus 1 would be negative 3. And x to negative 1, you go negative, bring negative 1 in front. There's negative 1 brought in front. And then x to negative 1 minus 1 is negative 2. Plus derivative of a constant is 0. Now, again, on future sections, I will not write 0. I'll just drop that one term. So this becomes negative 15x to negative 4 plus 4x to negative 3 plus x to negative 2. Now remember, we do not wish to have negative exponents, so the final answer without negative exponent would be negative 15 over x to the 4th plus 4 over x cubed plus 1 over x squared. And there you have that. And that's it. You don't need to get LCD for me again. This is good enough. Now let's take a look at number 30. In number 30, we have f prime of t. And okay, the first part I'm okay with. The derivative of that, constant multiple t squared, bring 2 in front. Subtract 1 from the exponent, you get t. Now, square root of t cubed. Remember, we don't have a rule for radicals, for derivatives. So I'm going to write it as a rational exponent. Remember, index is 2. So this is written as t to 3/2. The rule I'm using here is this. The nth root of a to the m is a to the m over n. This is the rule of exponents, which allows me to rewrite radicals using rational exponents. So this is going to be t to 3/2. And now we can actually take that derivative. So this is 4t plus t to 3/2. That's just the sorry. Let me write this first. 2t squared plus t to 3/2. Because this is the derivative. I just attached t to 3/2 in front of that. Okay, so I took the derivative of 2t squared, that's over here. Now, derivative of t to 3/2, bring 3/2 to the front. 3/2 is 1.5. Subtract 1 from it, you get 1/2. So all said and done, the answer is 4t plus 3/2, t to 1/2, and that is good enough. But if you like to, because the answer that has radical in it, feel free to write it this way. And that is also good. I'm flexible with this one. Okay, number 32. In number 32, let's rewrite both of these again. Square root of u. Remember, square root of u is u to 1/2. And cube root of u is u to 1/3. Okay, so I can rewrite now each of those radicals, and let's say this is just a function. Again, f of u is going to be u to negative 1/2, negative 3 times u to negative 1/3. Once you bring them to the numerator, they become negative. That's why. Okay, and then now I can take the derivative. F prime of u is going to be negative 1/2 u to negative 1/2 minus 1, negative 3/2 minus 3 times negative 1/3 times u to negative 1/3 minus 1 is negative 4/3. So now let's rewrite this whole thing again. So this is going to be negative 1/2 u to negative 3/2 positive u to negative 4/3. And in the last step, we can rewrite this as equals, let me move this up. This is going to be equal to negative 1 over 2 u to 3/2 using the negative exponent rules plus 1 over u to 4/3, and that should do it for this exercise. Okay, so with that we are done with section 2.2.